You are sitting still. At least that's what it feels like. Your chair isn't moving. The floor isn't moving. But right now, at this exact second, you are being carried east at somewhere between 500 and 1,000 miles an hour, and you cannot feel a single mile of it. You never have. No human ever has. For most of history, that was the argument against the whole idea. If the world were spinning, surely you'd notice. Surely a dropped stone would land behind you. Surely birds would be flung off. Astronomers had proved it with math long before anyone could show it. But in 1851, a French physicist named Léon Foucault made it something you could stand and watch by hanging a heavy brass weight from the ceiling of a Paris hall and letting it swing. The pendulum kept swinging in the same direction. The floor beneath it slowly turned. That's the part people get wrong. The spin isn't something happening to you. It's something you are part of. So the real question was never why you can't feel it. The real question is, what happens the moment it stops? Start with the version that kills you fastest. Imagine the planet's rotation halts instantly, not slows. Stops. The rock beneath your feet goes still, and nothing else does. You keep moving. So does your house, your city, the topsoil under it, and every drop of water in every ocean. All of it carries the same eastward motion it had a second ago, and all of it keeps that motion because nothing has told it otherwise. Inertia is just the tendency of a moving thing to stay moving. There is no break on the sky. The atmosphere is the part that matters. It isn't attached to anything. At the equator, it sweeps east at over 1,000 miles an hour. A wind faster than any hurricane ever measured. Faster than sound itself. Everything loose is scoured off the continents in minutes. The friction alone would set the air on fire. Would anything survive that? Almost nothing above the bedrock. But that version is a cartoon. Physics doesn't offer instant anything. So try the slower version. The one scientists actually model. Earth is not a sphere. It's slightly squashed, about 26 miles wider through the equator than through the poles. That bulge exists because of the spin. Rotation flings material outward, and over billions of years the planet settled into that shape like clay on a potter's wheel. The oceans bulge too. There is more water piled around the middle of the world than there would otherwise be, held there by the same effect. Now take the spin away, slowly. The bulge relaxes, gravity stops competing with rotation and simply pulls, and water goes where gravity is strongest, which is toward the poles. A geographer named Witold Fracek modeled exactly this, mapping where the oceans would end up on a still Earth. His answer is one of the strangest maps ever drawn. The Atlantic and the Pacific vanish as you know them. Water collects into two enormous polar oceans, one at the top of the world and one at the bottom. The middle of the planet dries out into a single unbroken continent, wrapping the entire equator, a belt of land you could walk around forever without ever crossing water. Half the surface of your planet would change identity. Would you still call it Earth? Then there's the sky. Without rotation, a day no longer takes a day. The sun would still cross your sky, but only because Earth still circles it. One trip around the sun would become one sunrise and one sunset. 6 months of unbroken daylight, 6 months of unbroken night. The lit half would bake, the dark half would freeze, and the narrow band of permanent dusk between them would be the only place left where anything could live. But none of that is the thing that ends you. Go down instead. 2,000 miles beneath your feet. The Earth's outer core is liquid iron, hot enough to stay molten and never still. That churning metal generates electric currents, and those currents generate the planet's magnetic field. In the 1940s, a physicist named Walter Elsasser worked out how. The moving iron behaves like a natural dynamo, a generator with no moving parts anyone will ever see. But a dynamo needs organization. What organizes Earth's is rotation. Spin twists the rising columns of molten iron into orderly spirals instead of random churn, the same way it curls hurricanes into spirals at the surface, an effect first described by Gaspar Gustave de Coriolis in 1835. Take the spin away, and the organization goes with it. The field weakens, then it collapses, and the invisible shell that has deflected the solar wind away from this planet for 4 billion years simply switches off. That's the real ending. Not the wind, not the flood, not the dark. The solar wind arrives unopposed, and the atmosphere, no longer shielded, begins bleeding into space one molecule at a time, exactly the way it happened on Mars. The oceans would drown the coasts, the core would kill the planet. Here's the part that should actually unsettle you. It's already happening. The moon pulls on Earth's oceans, and that drag steals rotation from the planet in tiny increments, handing it outward. The moon drifts about 1.5 inches farther away every year. Your planet's spin slows to pay for it. We know the rate because of detective work with ancient records. F. Richard Stevenson spent decades collecting eclipse observations from Babylonian clay tablets, Chinese court histories, and medieval Arab astronomers, records of exactly where and when the sun went dark. The eclipses didn't happen where a constant speed Earth says they should have. That gap between prediction and observation is the accumulated slowing written down by people who had no idea what they were recording. The number is about 2 milliseconds per century, almost nothing. But run it backward. When dinosaurs walked, a day was about 23.5 hours. Coral fossils preserve the evidence. Growth bands from 400 million years ago, showing a year that held roughly 400 days. Go back further still, toward the early Earth, and a day may have been as short as 6 hours. Run it forward, and the answer points the same direction. The spin is leaving. It has been leaving since the beginning. You won't be here for the end of it, neither will anyone. The sun will die long before the Earth stands still. But the process is not hypothetical, and it is not paused. The second itself had to be redefined because of it, pulled off the turning of the Earth and handed to atomic clocks, because the planet was no longer a reliable enough clock to keep. The ground under you is running down like a top on a table, and the only reason the day feels fixed is that your entire species has existed for less than a blink of it. So sit still for a second. You aren't. You never were. And 2,000 miles beneath you, the thing carrying you is very slowly letting go.